Hello, everyone! Welcome back to the Microcontroller Application Technology course. Today, we will learn about using a timer to achieve a 1-second sequential display of numbers 0 to 9. We will explore the following 4 topics. Previously, we learned to use arrays and for loops to display a countdown from 9 to 0 on a single-digit display. However, a countdown usually lasts 1 second. Today, we will delve into using timers to generate a standard 1-second signal to cycle through numbers 0 to 9 and display the result on a display. To complete this task, we need to understand both software and hardware design, as well as the relevant knowledge about timer. How do we implement this? Let's look at the registers related to timers. There are mainly 2. The Mode Control Register TMOD and the Control Register TCON. TMOD is the working mode register of timer 0 and timer 1, used to set the working mode of the timer. The commonly used mode is mode 1, which is a 16-bit counter. The other one is the Control Register TCON. TCON is responsible for controlling the start and stop of the timer or counter, indicating when the timer or counter overflows and the interrupt situation. The functionality of the timer counter is determined by software programming. Therefore, it is generally necessary to initialize it before use. In the C language, there are 4 steps to initialize the timer. The first step is to determine the working mode, which means assigning a value to TMOD. For example, TMOD equals 0x01 indicates that T0 is working in mode 1. The second step is to preset the initial value for timing or counting by directly writing the initial value into TH0, TL0, TH1, or TL1. For example, TH0 equals 0x3c sets the hexadecimal value 3c to the high 8 bits of T0, and TL0 equals 0xb0 sets the hexadecimal value b0 to the low 8 bits of T0. When the timer counter reaches its maximum count, it will generate an interrupt signal. The third step is to enable the timer interrupt as needed by assigning values directly to the IE register. For example, EA equals 1 enables all interrupts, and ET0 equals 1 allows timer 0 interrupt. The fourth step is to start the timer counter by setting TR0 or TR1 to 1, for example, TR0 equals 1 starts timer 0. When programming with the timer counter, it is essential to consider the following 3 points. First, timer-specific bits like TH0, TL0 must be in uppercase in the program, otherwise, compilation errors may occur. Second, the statement format for presetting the initial value can be written as TH0 equals 0x3c, TL0 equals 0xb0 or TH0 equals 65536 minus 50,000 divided by 256, TL0 equals 65,536 minus 50,000% 256. Both statements have the same effect. In the first statement, 50,000 is divided by 256, giving a quotient of 60, hexadecimal 0x3c, and the second statement gives a remainder of 176, hexadecimal 0xb0. The advantage of using the second statement is that it allows for easy adjustment of the timing. If you change the timing time, you only need to change the number that is reduced. For example, reducing 50,000 represents a timing of 50 milliseconds, reducing 20,000 represents a timing of 20 milliseconds. The statement for a 20 millisecond timing is similar to the one shown above, with only the value 50,000 changed to 20,000, making it very convenient. Thirdly, in C51, the format for defining an interrupt function is as follows, where n is the interrupt type number. For the 51 microcontroller, the corresponding interrupt type number and the entry address of the interrupt service program are shown in the table. Accordingly, the T0 interrupt should be written as void interrupt function _name1. Now, let's move on to designing the hardware circuit for implementing this example. The hardware circuit used in this example is as shown in the diagram. The display is a common cathode 7-segment display controlled by an 8-bit binary number output from the P0 port. P0.0 connects to A, P0.1 connects to B, and so on. To display a specific decimal digit on the 7-segment display, you just need to output the corresponding 8-bit segment code from the P0 port. The common cathode of the 7-segment display is connected to ground, making it always active. After completing the hardware circuit design, the next step is programming. The program consists of a main function and an interrupt function. The program flowchart is as shown in the diagram. Pay attention to the initialization of the timer, which involves determining the function and mode of operation, presetting the initial value, enabling interrupts, and starting the timer. Let's start by defining x as the variable for counting 1-second cycles and I as the variable for displaying the segment codes in a loop, and setting up an array to store the segment codes for numbers 0 to 9. In the main function, the P0 port is first cleared. The statement tmod equals 0x01 defines T0 to work in mode 1. The next two statements assign initial values to the high 8 bits and low 8 bits of the T0 timer respectively. EA equals 1 indicates that all interrupts are enabled. ET0 equals 1 enables the T0 interrupt, TR0 equals 1 starts the T0 interrupt, and finally, an infinite loop is entered. In the interrupt function, the T0 interrupt function is defined, and then the values of TH0 and TL0 are reset to the initial timing value. The statement x plus equals 20 is used. The if statement is used to check if 20 cycles have passed, indicating 1 second has passed. If so, the loop counter variable x is reset to 0. The array is displayed. The segment code for display is sent to the P0 port, and I is incremented to prepare for the next digit display. The subsequent if statements mainly implement the cyclic display of elements in the array. After completing the program design, the next step is simulation. First, write the program in Keil software and compile it to get a hex file. Then open Produce, the simulation software, and load the generated hex file onto the microcontroller chip. Start the simulation and observe if the 7-segment display shows the correct numbers. Through today's lesson, you should have learned how to use a timer counter and how to design a program to display numbers 0-9 alternately using a timer. Finally, here are a few homework exercises for you to reinforce the knowledge learned today and deepen your understanding. Please make sure to complete them diligently. That concludes this lesson. See you in the next class.